Welcome back to Advent of Code. Why is my webcam so dark? 1 second. Try that. Oh wow, that makes everything really slow. Alright, just go back to auto. Alright, so we're on day 8. Welcome in, DAJ. Oh boy, can't wait to get nothing but Ubisoft ads until Skull and Bones is released. What's Skull and Bones? Is that a new game? Haven't heard of this. Pirate game. People are always like, when Assassin's Creed Black Flag released, people are always saying like they should just make a full-on pirate game because that was essentially, well, in its own right, a really good pirate game. But people just wanted one without all the Assassin's Creed stuff. Well, good to hear they're finally making one. Yeah, it's about time. They're on. Now let me just get my coffee. Yeah, I mean, ever since I don't know, like Sid Meier's Pirates, the pirate genre has been kind of not being touched much. I mean, there's Sea of Thieves, but that seems to be pretty much just a multiplayer game. I assume Ubisoft's game will have a single-player campaign as well. The problem is it will have Ubisoft's cluttered as hell UI. Yeah. Well, um, oh, okay. Well, I guess we're starting. Music. All right, day 8, Haunted Wasteland. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. Okay. One of the camel's pouches is labeled maps. Sure enough, it's full of documents about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. After playing Souls games, I've really come to love minimalistic UIs. One of these days I'll have to play Dark Souls. I'm not looking forward to it, but I think it seems to be a very important piece of video game history now. Maybe it'll come up on the Wheel of Struggle at some point. Where was I? Oh, okay. It's a network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. I'm doubtful. After examining the maps for a bit, the two nodes stick out, AAA and ZZZ. You feel like triple A is where you are now, and you have to follow the left-right instructions until you reach triple Z. This format defines each node of the network individually. For example, triple A equals triple B, triple C. starting with AAA, you need to look up the next element based on the next left to right instruction in your input. In this example, start with AAA and go right. Oh, we've got this RL at the start. Go right by choosing the right element of AAA, CCC. Then left. Okay. By following the left to right instructions. Okay, that's easy enough. Of course, you might not find ZZZ right away. If you run out of left to right instructions, repeat the whole sequence of instructions as necessary. Okay. Oh, that's it? Okay, just do that. Pretty easy. And that's the left to right instructions. Okay. So as long as we just follow that left to right at each turn. Okay. I don't foresee any difficulty with part 1. And there's no real algorithm needed either. Alright. They're really taking pity on the coders after day 6. Yeah, it seems that way. Which means we're probably in for a tough one tomorrow. Well, I don't know, part 2. We'll see what part 2 is for this. I don't think there's much that could be done for part 2, though. That could be really difficult. Alright. So we want to, so the first line let's call it LR sequence equals line.strip. Yeah, okay. And let's just make that. Okay. And then just read an empty line. And then I wonder if you could just set up the IDE to auto-generate the open input file code when you make a new project. Yeah, I think some people do that, yeah. Well, usually, I've seen some people do console commands where they just paste in a console command and it just fetches the input. Whether you could set up the IDE to do that, I don't know, but at the very least, it's easy to just create a small script, or just, I mean, actually, just have a URL fetcher in code. So, as long as you know it's always going to be day 8, day 9. Yeah, in fact, I could even do that. So instead of open.txt, you just use the URL library in Python, which is pretty good, and just fetch the input as text. I think I'll do that tomorrow. We'll try it out. All right, no more having to copy and paste. Not only fetch it, but we can also paste it into this text file as well, so then I can actually see it visually. All right, so then we want to so basically we want an edge list. So edges equals, just say, dictionary. Let's say left, right equals line dot strip dot split. Split on the space equals space, and then let's just take the right. So it's going to be I could use what's it called? Eval exec. Oh, eval. Will that work? What will that get me? Does it return something? Yeah, so if I do print eval, right. Oh no, because those aren't strings. No, okay, whatever, we'll just do the parsing way. So we want right, so ignore the first and last characters. That gets us this. Dot split, comma space. That gets us those two strings. So we want list. And then we want to put that into the dictionary. So edges left equals that. So print edges. All right. So those are that's the graph. But the edges are ordered. All right. So we don't use a set. I would normally use a set here, but we use a list here. Now start equals AAA. Goal equals ZZZ. Or should we just say current equals AAA? While current is not equal to ZZZ. So also we want a LR counter equals 0, so that's going to be the index of the LRs. All right, so a single step. Also, we want to count how many steps we're taking. All right, so a single step means we first decide whether we're going left or right. So it's going to be LR sequence, LR counter, let's say edge index equals 1 if, no, 0 if that is left, else 1. Okay. So Then we want current equals. So you just do edges, look up current. That gets you the two left, right, the two branches. And then we want edge index here. That's it. And then we need to update stuff. So LR counter equals LR counter plus 1. But we need to divide it down to the size of LR sequence. And steps plus equal 1. Does Python not have plus equal? I wouldn't use it there because the modulus operator takes precedence, I think. Yeah, it does. I've made that mistake before. So that's it. So step goes up by 1 every time we've moved. So it should be 79. Pretty easy. Quite a small number. Not correct. It does seem quite small. All right. Let's try the example then. Wait, do we actually start at AAA, or is it... Is it whatever's first in the... No, it does say AAA, okay. Okay, so for this example... This example, we infinite loop? Okay. So it's supposed to reach ZZZ in 2 steps. Let's print out our current. We're stuck at GGG. What's going on here? GGG is a sink. If you get to GGG, you're stuck there forever. How did we get there? Right. We go right. Then it should be left. Alright, have I got these left-right things correct? Let's see. +1. Oh. No, I did strip it. Okay. I was worried that we might have the new line character in there. Alright, we'll print out the LR sequence anyway. That's too much printing. All right. RL. Okay, that's fine. So A, then we go right to C. Then we should be going left to ZZ. You don't have it loop back. What do you mean loop back? Oh, no, the problem is it's not, it's supposed to be capitalized. L and R are capitals. Oh, let's try. I did think at the time, oh, I should check if they're capitals. Nah, it's probably lowercase. Alright, there we go. 2. 23147. Yeah, that's more like it. 79 is small enough that someone could easily solve it with a bit of binary search guesswork. I mean, they could do that with this as well, but it'll take a longer time. But 79, you could actually do it by hand pretty easily as well. Just follow 79 steps. That's correct. Okay. The sandstorm is upon you and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all of the paths at the same time until they all simultaneously end up at nodes that end up with Z. For example, oh, I see what they're getting at here. There are two starting nodes, 11A and 11B. Oh, sorry, 22A. Alright, so you're at 11A and 22A. So you go left, 11B, 22B. Right, 11Z, 22C. Okay. So I think the trap here is that people are actually going to go and try and do those all simultaneously, and it'll just take forever. So I guess what we need to do is do them independently, find out how long it takes, and then find the least common multiple of all those numbers, which is, if you find the GCD, the greatest common divisor. Well, the puzzle does say simultaneously, but we can work out what the simultaneous would be if we just find the least common multiple of each of the individual loops. So, for example, if one takes... Oh... Yeah. So I assume they're going to get stuck in a loop. So we need to find how long, what their loop size is. Each individual loop sizes. So in this case, it's 2, for the first one, and 3 for the second one. Lowest common multiple of 2 and 3 is 6. So it's 1, 2, 3, 4, 5, 6 is when they meet up simultaneously. And those happen to be prime numbers, 2 and 3. But if they weren't prime, it still works. But it's less trivial to find the least common multiple, but Python has a calculator for that, so it's fine. LCM. What does it? But it's you just take the numbers, multiply them, divide by the GCD, which is the greatest common divisor. That's it. Okay, let's put that to the test. So I'm assuming the actual lowest common multiple will be like in the millions or billions or something. So if you actually try to do this, unless he's made this really easy, in which case it just works. I'm just going to do this the smart way. So so that's part 1. Alright. Part 2. So first we need to find all the starting points. So they said ends with A. Alright, so starts equals just pick out all the keys where S dot ends with A. Useful method, ends with and starts with. But it's not as trivial as that, because they might hit several different goals in a sequence with different lengths between them. So you need to find the sequence of goals they hit, unless it's set up that they only each hit one goal in one loop. I guess we can try and see. Because in this case, 11b went to 11z and it never went to 22. And 22b went to 20z and it never went to... We'll just try and see. Alright, so... starts equals so I think we need a method here. Define get loop. Alright, so given a start, we want to find when the loop starts, so i.e. the first time it hits the goal, and how long it takes before it hits that same goal. Now, I'm worried it might hit other goals in between, but let's just try this approach first. So we basically do this. So current equals start. we want LR counter equals 0. So while not current dot ends with wait, the LR sequence isn't even going to the LR sequence will be a different. The next time it reaches the goal, the LRs will be different. So it's actually going to go different paths. So the loop is very non-trivial here. I mean, I could try coding them all simultaneously, but I'm pretty sure he's designed it so it's going to take a long time. Right, we need to investigate. So let's just see what happens here. So while not current dot ends with Z, no printing. Edge index equals 0 if L1 current equals edges current edge index. Don't need steps right now. Okay, so at this point we are sitting on the goal. And we want to see how long it takes to get back to the goal. And I'm interested also to see if the LR counter will be the same or different next time it gets back to the goal. So let's say we'll print. So when we get here, I want to know the LR counter. Now we want to just do this again. Well, we don't want this while condition because we're sitting on a Z. We want basically a do while loop, which is no one really uses do while loops anymore, but it's like, okay, we can say okay, hacky way of doing this, just say first equals true while not first and okay, and just first equals false. I don't know a better way of doing that. All right, so so do at least one iteration of this loop before we continue. All right, so so it's just the same stuff. So we want to print current and LR counter. Also, we want to count the steps. So now we should be sitting at another goal, possibly not the same one. So I'm interested to see what now the and the number of steps it took. Alright, let's just try that. Get loop starts, just the first start. Alright. DH. DHZ. Wait. Oh. So DHZ is a sync. It just stays at DHZ, does it? Well, that's correct, I guess. Where is it? No. Shouldn't be a sync. Also print the starts. So we start with NPA. And we arrive at DHZ. That's probably correct. LR counter is reset to 0, apparently. I suppose that could be the case. And now doing this while not first and not current or ends with Z, so we should execute at least one step. Why is this 0? The whole point of this first thing was to stop it from just staying put. Oh, no, I've done this wrong. Hang on, first. No, this is going to break out immediately. I want while... What am I trying to do here? Okay, this is nonsense. Take this out. We're actually trying to say... It's while it doesn't end with Z. This shouldn't be complicated. I'm just trying to make it do one iteration of this. Okay, so when it ends with Z, it's going to break out of this while loop. How do we stop that? We just want to say the first time first is going to be true. Ah, it's OR. So, well, first OR that. So the first... That forces it to be true the first time, and then it ignores first. That's what I should be doing. Alright, so it looped back to the same current, and took that many steps, and the count was the same. That's lucky. So should we try each of these then? Or start... We may not be so lucky. Depends how this was designed. Why is it always 0? Why is LR count always 0? That doesn't feel right. It's saying that whenever we get to a goal, LR counter is just happens to be at 0. That is the case originally as well. Is that just a consequence of the way this is designed? That it always uses one full iteration of all the left-right steps? Maybe. Okay, we don't need to question it. I mean, seems correct. Okay, so that's a good sign then. It's just... So... At 19631... Wait. We need to also print the steps. So, how do we do this? So we want to say... number of steps, and that's the counter. Alright, we don't care about the counter anymore. Apparently that just resolves itself, so that's fine. We want to see the steps it takes to get to... Alright, so it takes 19631 to get there, and then 19631 for the next loop. Well, these numbers are too perfect. Maybe he's I think he's just made it this way. This just makes it so much easier. Okay, so what it's saying is, it's saying every 19631 steps, it's going to hit a goal. And that includes from the start. So it takes 19631 steps to get there to goal, and then 19631 steps to go in a loop and hit the goal again. Fine. So is it then just the lowest common multiple of those numbers? So if we return steps, so loop sizes equals, so it's going to be get loop start for start in starts. Print. I want LCM. Ah, nice. There is some. I thought I might need to calculate it using GCD, but it's got LCM in the math library, so I don't think it used to. Well, it probably has for many years now. I just haven't realized. Okay, LCM of... And it accepts multiple parameters as well, not just 2. So we just want to find the lowest common multiple of the loop sizes. But how do you... I forget how to do this now. Is it star or something? There. So if people are trying to run them all simultaneously, it'll take that many steps before they all arrive at the goal. Well, let's see if this is correct. I mean, it feels all neat and tidy, so it seems like it's going to be correct. I think he was just really... Yeah, it is. He's made this line up really nicely. You could have made this harder if they all arrived at different times. Then it's not just a lowest common multiple. You need to account for all the offsets. So basically you're solving a set of linear equations. Which still works, but you would need to use, I think, the Chinese remainder theorem. Maybe. As long as they're pairwise coprime numbers. Because... Oh. Light mode. I'll have to look into my browser settings for that. I don't know exactly what you would do. Probably, yeah, it's just a bit more complicated if they don't line up nicely. But he's made them line up perfectly, so it's they all reached the goal in the same amount of time as it takes for one full loop, which is yeah, okay, so he could have made it much harder. I think a lot of people still might get stuck on that because it is a little bit mathematical, but not as mathematical as it would have been. I think, hello Maro. This one looks easy, but I haven't started. It's kind of easy. But not exactly trivial. Okay, part 2 is, I would say, needs a little bit of mathematical insight, but even you don't need to know any theorems or anything, so even without that you can reason it out, but you probably need to draw a diagram or something to understand. But he's made the numbers really neat and tidy, so it's kind of really generous. You can design your program to handle the general case, and that would be much harder. But he's made it so that you don't really need to do it in a complicated way. It took Hex 45 minutes. Yeah, it seems like 30 to 45 minutes is roughly the time I'm taking for the easy the easy problems. Mainly because I'm explaining everything each step, but playing Doom today, I don't know yet, I haven't decided. I could do a short stream where I just do a few chapters, maybe. Just to get a feel for it. We'll be playing with GZ Doom, so I don't know how much different that is to the original Doom, so using the GZ Doom engine. I mean, it's preferable. I'm all for using new engines to play old games. Alright, so this is the stats. It looks like, well, it's always going to be fewer people solving it, but people did get stuck on part 2. It's like 50-50 completion rate. Understandable. So I do expect a lot of people are just going to code it, because so in a lot of these problems lately, you just have to code it the way that the example described, kind of, and it works. Like here, you didn't have to use the quadratic equation. You could have, but if you just coded it the way the example described, it would just work. He could have made the numbers in the billions, in which case you would have to use the quadratic equation. But he didn't. He was nice. Part 2 completion rate of day 6. Yeah. Yeah, what was part 2 again? It was just... Yeah, just for that big number, but it wasn't even that big. So yeah, you didn't have to code anything, you could just manually paste those together and just plug it in. I mean, that question, you could have put that on a GCSE maths exam, as is, and students would have been expected to solve that without even using a calculator, just standard, using the quadratic equation, find the crossing points. So, you know, that's very much, you know, at least in the UK, we'd have been expected to solve that using pen and paper. Alright, so let's have a look at the leaderboard. Day 8. 4 minutes 24, yeah. Makes sense. I mean, LCM. I don't know if these guys coded it for the more general case where you've got offsets as well. It's not that much harder if there's offsets. You just need to write something to solve a set of linear equations. But it's just 38 seconds to solve part 1. Believable, but he's paused it pretty quickly. 1 minute, yeah. I mean, the Python has eval, so if you just eval a lot of that, actually, you don't need to do much parsing. Well, I'm not sure eval would really work with these variable names, but you can sort of tinker with the input to make it work. Private leaderboard. Yep, people are catching up. Cool. So, yeah, I mean, I thought that was an easy day, but easy day from the perspective of a mathematician, I suppose. We're almost up to 200,000 people solving day 1. Well, okay. Let's start working on the video then. Paste that to YouTube. So, yep, that's it. I don't think you would even need to go as far as using the Chinese remainder theorem here. I think it's well, you might need to, but yeah. Chinese remainder theorem is one of those things we briefly covered in school, but it never really comes up, and so I always forget how to use it or where you're supposed to use it, because they don't really like giving questions on this kind of modular arithmetic stuff. It is something that would often come up in the International Maths Olympiad. They loved modular arithmetic, but I was never good enough for the IMO. I maybe I got to the second round of BMO, British Maths Olympiad, but I think I could have been good at that stuff, but I was never taught. Like, the actual competitors, they had like training camps where they would like spend a whole week learning all these Chinese remainder theorem and various formulae and stuff that you're supposed to use. I didn't really know any of that, so they love their Euclidean geometry problems as well. Lots of geometry problems where you gotta use ruler and compass methods to work out what an certain angle is. So it's not something that really ever gets covered properly in GCSE or even A-level mathematics. Not even in university level, to be honest. Well, yeah, it does get covered in university level. All right. That's it then. All right, so day 9 predictions. I think it'll be a hard one. We'll see. 3 hours. I guess I'll have to start earlier tomorrow then. All right. Well, see you guys tomorrow. Bye bye.